Today's aim is that students will be able to solve linear equations in one variable and determine when a linear equation has no solution or infinitely many solutions. So some vocabulary to start with. 1. A contradiction is when an equation simplifies to the form a equals b. So for example, 3 equals 4. This is never true, so we say the equation has no solution. An identity is when an equation simplifies to the form a equals a, or for example, 3 equals 3. This is always true, so we say that the equation has infinitely many solutions. Some key points. When you have an equation with fractions, to get rid of the fractions, multiply every term by a common denominator. If you solve an equation and the simplified version is never true, then you write the equation has no solution. If you solve an equation and the simplified version is always true, then the equation has infinitely many solutions. Finally, if you solve an equation, the simplified version is in the form of x equals some number, then the equation has one solution. So let's look at some examples. The directions say solve each equation. If the equation is an identity, write infinitely many solutions. If the equation is a contradiction, write no solution. So let's look at the first example. When we're solving equations, we always start by drawing our line straight down from the equal sign. Then I look at the left side. There's nothing I need to simplify on the left side of the equation, so I just rewrite that, 24a minus 22. Then I look at the left side of the equation. Well, here I have parentheses, which tells me I know I'm going to need to distribute, get rid of those parentheses. I'm going to multiply this negative 4 by each of the numbers inside the parentheses. Negative 4 times 1 is negative 4. Then remember, I think about this as a negative here. So negative 4 times negative 6a. A negative times a negative gives me a positive, so I write my positive 24a. 4 times 6 is 24, and we have an a that we need to bring down. Now there's nothing I need to simplify on either side, so I'm ready to start moving things from one side to the other. I want to collect all of my a's, all of my variables, on one side of the equation. And I want to move the number with the smaller coefficient. So I look at this one and this one. Well, they're the same, so it doesn't really matter which one I move. Let's say I move this one. I'm going to subtract 24a from both sides. I'm going to subtract it directly underneath the other 24a. So these cancel out. But these also cancel out because 24a minus 24a is just 0. So I'm left with negative 22 equals negative 4. Well, we know that's not true, so I'm going to put a little slash through that. So I know that this is what we call a contradiction. This is not true ever. Negative 22 is never going to equal negative 4, so this is a contradiction. And I write there is no solution. So my answer is no solution. I cannot find the answer to this problem because there is no solution. Let's look at the second example. First thing, I draw my line directly down, and I simplify each side of my equation separately. So I'm going to do negative 1/2 times 36a, and then times negative 6. Now this is a little trickier because there's a fraction in there. So I'll do my fractions down here at the bottom. I have negative 1/2 times 36. I know there's an invisible 1 down underneath any whole number. And I multiply straight across. Negative 1 times 36 is negative 36. 2 times 1 is 2. And I know negative 36 divided by 2 is negative 18. So I have negative 18a. Now I need to do negative 1/2 times negative 6. I'll do that down here at the bottom. So I have negative 1/2 times 6. I know there's an invisible 1 underneath the 6. Multiply straight across, I have negative 6 divided by 2, which is negative 3. Another way to think about this is, what's half of 6? Well, half of 6 is 3. A negative times a negative is a positive, so I have positive 3. Oh, here I forgot to put my negative. Whoops. So these should have both been negative. It should become a positive there. So we now have positive 3. And now we go to the other side of the equation. We're going to need to distribute on this side of the equation too. So I have 3/4 times 4. And I'll do this down here at my bottom of my paper. I have 3/4 times 4. I put my invisible 1 underneath the 4. 3 times 4 is 12. Divided by 4 times 1 is 4, which gives me 3. So I have 3 And then I have 3/4 times negative 24. Remember, I think about this as negative. So if I do that over here, I have 3/4 times negative 24. I put my invisible 1. 3 times negative 24 gives me negative 72. And 4 times 1 gives me 4. Well, negative 72 divided by 4 gives me negative 18. So I'm going to put minus 18a. Remember, a negative and a subtraction are the same thing. Now I've simplified both sides of my equations and I'm ready to move my variables. I want to undo addition or subtraction. It doesn't really matter which one I pick because they're the same. Let's say I add 18a to both sides to undo this negative here. Well, I'm going to have the same problem I just had where both variables cancel out. This cancels out and this cancels out. And I'm left with 3 equals 3. Well, I know that that's always true. 3 is always going to equal 3. That's an identity. It's always true. And so I'm going to write that it has infinitely many solutions. No matter what number you plug in, every single number in the whole wide world is going to work. You can use a equals 10. You could use a equals negative 2, a equals 15. Anything you put in for a, the answer is still going to work out. You have infinitely many solutions. Now we're ready for our last example. Draw a straight line through my problem. And again, I'm going to multiply 1/2 times 4. Now this I know I can just do in my head. 1/2 times 4. So what is 1/2 of 4? Well, half of 4 is just 2. So I'm going to write 2. Then I have 1/2 times negative k. So there's an invisible 1 here. 1/2 times negative 1. Well, anything times 1 is itself 1/2. And I have a negative, so it's going to be minus 1/2, and I need my k. Equals 2/5. There's nothing to simplify on the right side. Now I still have these fractions in my problems. Remember back here, my fractions went away after I distributed. But here I have these fractions and I don't really want to deal with the fractions. So what I want to do is think about, is there a common denominator between 2 and 5? What common denominator could I find? Well, I know that the common denominator between those would be 10. So if I think about my key points again, to get rid of fractions in an equation, multiply every term by a common denominator. So I'm going to multiply the whole equation by 10. I'm going to multiply this side by 10. There's my multiplication. And I'm going to multiply this side of the equation by 10. So everything gets multiplied by 10. Well, now I have these parentheses that I just drew with my 10 on the outside. So I'm going to need to distribute so that I can multiply 10 by everything on this side. So I have 10 times 2, which gives me 20. 10 times negative 1/2 k. So half of 10, half of 10 is 5, and it's negative, so negative 5k. And over here, I know I have my invisible 1 underneath, and I'll multiply straight across. 2 times 10 gives me 20. 5 times 1 gives me 5. Remember, when you have two parentheses next to each other, there's an invisible multiplication. Now, 20 divided by 5, of course, is just 4. So by multiplying everything in my equation by 10, I've gotten rid of those fractions. Now, you could do the problem with the fractions, but it makes it a little more complicated. Now I'm ready to undo addition or subtraction and get the k all by itself. So I want to move this 20. I know there's an invisible positive in front of it, so I'm going to subtract 20 from both sides. That gives me negative 5k equals 4 minus 20, or 4 plus a negative 20, which is negative 16. Now I'm going to divide by negative 5 on both sides. Now you can tell this isn't going to come out evenly. That's okay. Sometimes we get fraction answers. So we have k equals, and now I need to do negative 16 divided by 5. So I'm going to do 16 divided by 5. I know a negative divided by a negative is going to give me a positive. So I know my answer is going to be positive. 16 divided by 5, well, it goes in 3 times evenly. That gives me 15. If I subtract 1, that gives me 1. So it's going to be 3, and then this remainder 1 becomes my numerator, 1/5. 3 and 1/5. So k equals 3 and 1/5. Now it's time for you to practice.